So far, the two lessons we've done, the first lesson and this lesson, has revolved around limits, finding limits, right? So if you remember from the very beginning, there's three ways to find a limit. Graphically means if they give you a graph, analyzing it that way. You guys did that. Table, rare, right? But that's how we do it. They'll always give you the table filled out. They won't ever give you the table. The ones that I have seen will be like this, and then you just need to analyze it. What's the limit at 2? What's the limit at whatever, okay? And then the last one, which we spend the most time on, which is analytically, algebraically, right? So when we're doing that, that's the most common one. We have, steps, right? First step, always. Either do it in your head or do it on paper, but your first step is always plug in. Plug it in. If you get any kind of answer, negative, positive, fraction, decimal, 0, that's your answer, move on, right? If we get something, if we get a non-zero number over 0, 12 over 0, negative 10 over 0, things like that, D&E, we're done, move on. There is no limit, the limit doesn't exist, right? If we get 0 over a non-zero, that's just 0, okay? The big one is 0 over 0. If we get 0 over 0, that means we're not done yet. We have work left to be done, right? What is that work? Well, factoring. We did some factoring. That's the one we worked on last time. How do you know if you need to factor? Well, do you have binomials, trinomials, or polynomials? Is there multiple terms? If there is, chances are that's going to be the path. Common denominator, we haven't done yet. Usually that's when we need to add or subtract fractions, okay? Multiply by the conjugate. That one is big when we have roots, because you can't really factor roots, right? If it has a square root or a third or some kind of root, it's usually multiplied by conjugate. So that's usually how I kind of decide which method I'm going to go down, right? If I plug in and I get 0 over 0, okay? So we did factoring last time, so we're going to focus on the last two today. I'm going to give you examples of those. All right. Okay, so example 1E, this guy right here. It's important not to skip the first one, not to skip plug in, right? Some of these you can do in your head. Some of these you can plug it in your head. Some of you can plug in 3 and figure out what you get. That's okay, but as long as you do it, right? So if we were to plug in 3, right, what would we get? 0 over 0, right? Because we'd get 3 plus 1 square root minus 2, 3 minus 3. 3 plus 1 is 4, square root is 2, right? Minus 2 is 0. 3 over 3 is 0. Okay? So there we got here. Okay, so now which of the steps we're going to use? Well, again, kind of use these. If you have a root, you can't really factor that. It's not factorable. It is, but it's not something we do in this class. When we have square roots or third roots, we don't really factor those. We have other ways. That's where we're going to multiply by the conjugate. Okay, so what does that mean? Well, multiply, you guys know what multiply means. Conjugate is something similar. So watch, let me show you. So let me rewrite the problem. I'm going to rewrite the problem. Limit as x square root x plus 1 minus 2 on the outside, and then x minus 3, right? Okay, so we already tried plugging it in, and we got 0 over 0. So we know we need to continue, right? This one, like I say, when you have roots like this, multiply by the conjugate is going to be your way to go. So what do I mean by multiply by the conjugate? Well, you're going to multiply. So we're going to multiply, right? We're going to multiply by the part that's causing the issue. Well, the square, the root, is the one causing the issue. If that root wasn't there, I wouldn't know what to do. But it's the root that's causing the issue. So I'm going to multiply by the conjugate of the top. Right? I'm going to multiply by the conjugate of the root. But I can't just do the root, I have to do the whole thing. So over here, I'm going to write square root x plus 1 and a 2. The only difference with a conjugate is the sign in the middle changes. So instead of -2, it's going to be +2. That's what a conjugate is. So if you say square root x minus 4 plus 6, the conjugate would be the exact same thing, except it would just be the opposite sign. That's what we call the conjugate. It could be like that, or it could be x squared minus 6. The conjugate would be x squared plus 6, right? It's just a different sign. Okay? So I multiply by that. But the problem with the fraction is if I multiply just the top of a fraction by something, it changes the value. So how do we neutralize that? We multiply both the top and the bottom by the same thing. Multiply both the top and the bottom by the same thing. When I do that to a fraction, it keeps the fraction the same. Yeah, because I don't want to change the fraction. I just want to kind of simplify it. Okay. So now, the bottom I'm not going to change. It's multiplication, right? How do we multiply fractions? What's the trick or what's the rule for multiplying fractions? Does anyone remember? That's dividing. You're close. That's dividing fractions. It's even easier than that. Straight across. Just straight across, right? How do you multiply 3 over 2 times 1 over 2? Just straight across, right? Straight across, right? So that's what I'm going to do. So the bottom is x minus 3 times the conjugate, right? So I'm just going to rewrite that part, right? It says multiply, but I'm not going to multiply, and I'll tell you why in a second. What I'm going to multiply are the conjugates. How do I do that? There's an easy way, and there's a longer way, okay? What's the relationship between the yellow and the green? What's the relationship? There's a couple relationships, but tell me a relationship between the yellow and the green. What do you notice?
X plus 1 is square rooted.
Mm-hmm. There's a square root both. Both of them have square root. Good. What else? What's the same? When I say evaluate the relationship, it means what's the same, what's different. So they both have square roots, x plus 1. What else is the same or different?
Positive 2 and negative 2?
Difference, right? Difference. One has a positive 2, one has a negative 2. Is there any other difference besides that? We know one has a negative in the middle, one has a positive in the middle. Is there anything different besides? Are there any differences besides those two? It's not a trick question. No, there's not, right? There's not. They're exactly the same, except one has a negative 2, one has a positive 2. They're called difference of squares. Difference of squares, right? So back in Math 2 and Math 3, you talked about difference of squares. We actually talked about it here last week too. So I'll give you an easier example. X plus 5, the conjugate would be x minus 5, right? If I were to multiply these two together, how would I do that? If I were to multiply this binomial with this binomial, how would we do that? Distribute, right? FOIL. It's called FOIL, right? You guys probably learned it. Multiply the first two terms together. What do I get when I multiply x times x?
X squared.
There you go. What do I get and then first, F is first, O is outer. What do I get when I multiply the outer? Negative 5x. What about the inner? Positive 5x, and then the last, right? So I get negative 5x, positive 5x, negative 25. And then when I simplify that, what does it simplify to?
X squared minus 25.
Right? Let me give you another one. How about this? X plus 7, x minus 7. Now, without having to do all of those mechanics, what do you think it's going to be? There's a relationship there, right? There's a relationship there that when we multiply conjugates, right? Let's try this one. 2x plus 1, 2x minus 1. What do you think those are going to be? 4x squared. Keep going. Minus 1. Good. Right? We can do that with this guy here. So tell me what we're doing. Tell me in words, how are we going from this side to this side? How are we going from here to here? Here to here, here to here. In words, tell me what we're doing.
We're multiplying the first term, and then we're slapping on the multiplication of the second term.
Look at the first term, right? We're squaring it. What's 2 times 2? What's x times x? What's x times x? Right? We're squaring the first term. What are we doing to the second term? Multiplying them. We're squaring them, right? They're always the same number, right? That's what we're going to do here. We're going to do that here. So, what's the first term?
X plus 1 on square root.
Square root x plus 1 squared, right? What sign is it always? Minus. So we know there's going to be a minus here. And then what numbers are we multiplying in the second parentheses? Squared, right? That's the easy way. The hard way is by doing FOIL with that, and then you have to deal with square roots, and this is just the easier way to do it. I'll give you another problem like this to try on your own a little bit later, so you can kind of get used to it if it's still not clicking. Okay, so let's talk about this part first. It's a square root squared. What happens when I square a square root? Just becomes what's inside, right? Squaring a square root is like taking 2 steps forward and then taking 2 steps back, where you started, right? So instead of square root x plus 1 squared, it's just going to be x plus 1 minus. What's 4? I just said it. What's 2 squared? 4. You just multiplied it. Okay? Yeah, go ahead. Let me get you a pass. Yep, you're good. Go for it. The bottom, again, we're not going to multiply because they're not conjugates. And because if we did this right, it'll take care of itself. Okay. We can simplify the top, right? What does the top simplify to? X minus 3. Now, if I did this right, something's going to cancel out. What's going to cancel out? The binomial x minus 3. So in its place, what is it? When we cancel out, I know we say cancel. So it's not cancel. Cancel means just go away, right? So it's not really canceling, it's more simplifying. So when we simplify, what does it become? A 1. So what we have is 1 over it's the simplified version. That's multiplying by the conjugate. So that's what I mean by multiply the conjugate. When you have roots, that's what you're going to do. Okay? So now, let's move this guy down, and let's find the limit. The limit as x approaches 3 for 1 over square root x plus 1 plus 2. Once we do each of these things, then we got to plug it in. Now when we plug in, do we get something other than 0 times 0?
Yeah.
We do, right? We get 1 over 4. That's the limit, 1/4. Okay, that's the limit. So do you guys want another one like that, or do you want, so we have 2 more problems, and we have 1 more problem here. It's a different type of problem. And then I have 2 practice problems I want to give you, and then we're going to be done for today. So do you want the practice problem that looks like this right now, or wait till later?
That one.
Wait till later, or give it to you right now?
That one.
Give it to you again? Okay, so let me give you a practice problem. Let me give you a practice problem. So we'll call this one I, since the last one we did was H.
Are we going to do that?
What?
Are we going to do that?
Yeah, we'll do F in a second. Okay, so let me give you a problem. Yeah, the nice thing about this class is you won't ever see anything imaginary. We only deal with what's real. No imaginary numbers.
We can deal with the real numbers.
That's one of the nice things about this class is that if you get an imaginary, it doesn't exist to us. We don't care about anything imaginary. So find some space. 0, yeah. As x approaches 0.
Man, really run options. Try and get 0, 0.
Okay.
Here's one. How do we get to?
All right. So plug in 0. I get 1/3 minus 1/3 over 0, which is 0 over 0. Okay, that's when we know we need to try another method. So the method I'm going to try is common denominators. So I'm going to do that over here. So I have 1 over x plus 3 minus 1 over 3. Okay. X plus 3 is already factored. The only thing I can divide, because there's a 1 here, right? The only thing I can divide them by is 1. So that's just x plus 3. And 3 is just 3 times 1. So this guy over here needs a 3, and this guy over here needs an x plus 3. So the common denominator is x plus 3, x plus 3. Let me move it to the fraction. This guy needs a 3. This guy needs an x plus 3. So we get 3, and then I distribute the negative. I get negative 1x minus 3. Threes cancel out. Negative x over 3x plus 3. That guy, oops. I'm going to move back in. So I'm going to rewrite the problem. Negative x over 3x plus 3 over x. Plug in 0, you still get 0 over 0, right? Because you're going to get negative 0, right, over 9, which is 0, over 0, right? So 0 over 0, keep doing work. Well, the work we need to do is just rewrite it differently. It's not necessarily anything we need to do, just rewrite it differently, right? So we have the limit as x approaches 0. We have negative x over 3x plus 3 divided by x over 1 or just x, right? You can put x over 1 if it helps you remember, because sometimes you forget what I'm going to flip. So then you get the limit as x approaches 0, negative x, 3x plus 3 times 1 over x, right? These guys cancel or simplify. You get negative 1 over 3x plus 3. Now we can finally plug in and we won't get anything 0 over 0. Okay, that's it. So the last thing I'm going to tell you isn't necessarily a problem I'm going to give you, it's just you might see it. So absolute value bars, absolute value. Let me give you an example. I didn't put an example like this. I should have, but I didn't. So first of all, absolute value are the bars, right? What do the bars mean?
It's a hexagonal form, or like it's just gonna stay x basically.
It's going to be positive. The answer is always going to be positive. What makes it positive? What makes those bars always be something positive and never a negative answer, right?
It's just
Difference from 0.
There you go. How many steps am I from 0? So for example, if I have the absolute value of 3, how far is 3 away from 0 on the number line? 1, 2, 3, right? What about the absolute value of negative 3? Still 3 steps, right? You can't take negative steps, right? You can't take negative steps. You can only take positive steps, right? Negative steps would mean going back in time. We can't do that yet. Okay, so let's say, what's the first thing I'm going to do? If I look at this problem, what's the first thing I'm going to do to solve this thing? Plug in 0, right? Plug in 0. What happens when I plug in 0? I get 0 over 0, right? And doesn't that mean I'm not done yet? Well, what do? The answer is you're not going to do anything except draw a picture. Draw a picture. It's not as hard as you think. Trust me, it's not as hard as you think. Anytime you see absolute value,
no. Oh my God. This is that picture.
it's actually not as bad as you think. So this is where x approaches 0, right? Isn't that's right in the middle.
Yep.
So we want to see what's going on around that. So what happens at 1? What happens when I plug in 1 to my function? What do I get? 1 over 1, right? Over 1, up 1. What happens when I plug in 2? 2 over 2, which is also positive 1, right? That's going to happen throughout all of these guys. It's going to go this way forever and ever and ever, horizontal line. Now, what happens if I plug in negative 1? Can't plug in 0, we just said, because it's 0 over 0. What happens when I plug in negative 1 over here? What am I going to get on top? 1. What am I going to get on bottom?
Negative 1.
What do you get when you divide them? Negative 1, right? So that means the dot's down here. Plug in negative 2. What do you get? Positive 2 over, which is negative 1. Close.
You get one of these.
It goes that way, right? Well, what the heck is it doing? So without having to get any more, where is it going to be when x is positive?
1.
Positive 1, right? What is it going to be when x is negative?
Negative 1.
So really, I have a circle here because we can't have an answer, right? So looking at that picture, what is the limit as x approaches 0?
D and E.
There you go. Why is it D and E, Damon? You're right.
It approaches 2 different.
Yeah. At 0, it approaches two different numbers. One's positive one, one's a negative one, right? It's D and E. So the moral of the story is anytime you have an absolute value, because they'll throw one in from time to time, draw a picture for anything in this class. We don't do limits of absolute values. We draw a picture. We don't do derivatives of absolute values. We draw a picture. We don't integrate anything with absolute value. We draw a picture. Okay? So absolute value, draw a picture. It's a lot easier to do it that way than by trying to use our steps that we have over here, because it won't work. Okay? So tomorrow I'm going to give you the practice, and then we'll do the practice in class. If you have any questions, you can ask.